Hi everyone, am I audible? Please confirm. And is my screen visible? Anyone? Please confirm by typing in the chat box, then we can start the session. Anyone? Great. So this is how this session will be conducted. So it's a tutorial session where I'll be solving some basic problems for you guys, right? And my name is Rupesh Kumar, and I've been taking these sessions for this semester for the NPTEL course, Problem Solving through Programming in C. And yeah, so I will be explaining things on my screen and why my and you will through the mic you will be listening to me, right? And if you have any queries, then you will be communicating to me with via the chat box. So if you have any queries, type in the chat box and I will answer your query, right? At any instant you face technical glitches like my screen is not visible or I am not audible, then please share the query with me at that instant itself by typing in the chat box, right? And most probably if everything is stuck but others can see, then this means there is some network issue on your side, but still sometimes there might be network issues on my side, so you need to inform me at that instant itself, right? So let's start this session. So let me take up one problem from the last week that I was not able to cover in the last week. So you all are familiar with the concept of recursion, everyone? So recursion was something that was taught in the previous week, and I was not able to cover up that topic in the last week. So I want to ask you guys, are you familiar with recursion? Anyone? Please answer. So what is a recursive function? A function that calls itself, right? A recursive function is a function that calls itself. So for example, if you look at this function here, int fun, the function name is fun. It takes an integer variable n and it returns integer, right? Now inside the function you can see if n equals to 4, return n, fine, else return 2 into f fun of n plus 1. So I'm calling the function again at value n plus 1, right? So you can see this function is calling itself with the value n plus 1, right? So why? So this is a recursive function. And I hope you all are familiar with the idea how recursive functions work. Fine. So how to solve these problems? So how to, first of all, how to decode what the recursive function program is saying. So how to get an output from a given recursive program. And then second thing is how to write your own recursive programs, right? So there are a few basic things in this recursive functions. The first one is for any recursive function, there are three important cases that will arise, right? So if a function is recursive function, right? If you are doing recursion, if you are doing recursion, so there are three important things. One is base case, right? Then the other one is step one that should be here. The second thing that should be present in a recursive function is the recursive case, right? So that the second case has to be the recursive case. So these are two important things that should be present in a recursive program. Why we need the base case? What is the importance? The importance of base case is to terminate the program, right? Termination. And recursive case, for whatever problem you are going to solve, right? Hmm. So these are two basic constructs that are required in any recursive function. And the third most important thing is uh, all the program should be robust in the sense that the recursive gate should should eventually eventually lead to base case, right? The recursive case should eventually lead to the base case. What do I mean by this? So, for example, let's say you have a recursive function that looks like this. Uh, let's say you have a function f that takes some input x, right? And in this, there is a base case. Base if base case is true, what you do? You simply return one, let's say, right? Else, now this is the recursive case. In this case, what you have to do? You have to have with some new value of x, right? You have some updated values of x. Now, let's say I say if x equals to 0, return 1, else return else what you have to do? You have to call uh, f of x plus 1, right? Plus 1. So can anyone tell me what will happen for this recursive program? So I'm just trying to get to the point where why these constructs, why these conditions are required, why there should be a base case, where should be recursive case, and why the recursive case should eventually lead to the base case. Anyone, can you answer me? So what will happen for this program if you have some recursive function that looks like this? No one is answering. Am I audible? Great. So I believe let's go through this program, this program, and then we'll get to know what I'm talking about, right? So I believe the concepts are a bit sketchy for you guys right now. So I will just solve this problem. So is this problem clear, everyone? Can you see this program, what I have written on the screen? Is this clear, everyone, what is going on in this program? So let's forget this problem that we are going to solve. First, let's understand a basic example of recursive function, right? So let's say in the main function. So in the main function, what you do? You call this function f with value, let's say 2, right? So what will happen? So let's see what will happen, right? So when as soon as you call function f here, what happens is, so this is the main memory stack. Let's say this is the main memory, right? Main memory. And you all know how functions are executed in C program, right? Whenever you call function f, what happens? The pointer address to the main function, all the data to this of this main function is stored on the stack in the main memory, right? Stack. So a stack is created, and so the program main with all its variables is stored onto the stack. So main program is stored here with all the variables and the line number. Say, let's say this is line number 1. So it says you have to start from line number 2, right? And now what happens? Control jumps to the function f of 2, right? So let's get into the function f of 2. Then what happens? Yeah. in and line number 2, right? Now then what happens? F of 2 is called. So as soon as you call function f of 2, what happens? You go inside the body of the function, right? And the input is x equals to 2. So is the base case true? No. So for the first iteration, for the first step, what happens? X equals to 2, right? So this base case is not true. So the control jumps to this else part. And now what is happening? You are calling another function inside this function. Then what will happen? The function memory f, the call to the function fx, f of 2 is stored with the line number where from next line from where the program has to start. So let's say the line numbers are 1, 2, 3, 4. So it needs the information like from which next line we have to run it, right? So the next line is line number 5. You have to start from line number 5 and you call function f of x plus 1. So what are you passing here? Now x becomes 2 plus 1, 3, right? And again, I'm calling a function f with value 3. So now x becomes 3. And then again, your base case is not true. So again, it jumps to this else part. And again, you store this function f of 3, right? Onto the stack, program stack. And you know you have to resume from line number 5, right, everyone? Then again, you see in the else part, you call f of 4. So line number 5. So line number 5, right? And again, you know this does not match the base case. Again, you call f of 5, line number 5, right? Again, the base case does not match, and you again call the recursive function f of 6, line number 5. Now, when the value of x is 6, again it goes back to the else part. Then what happens? So if you pay attention to the main memory here, so let's say this main memory had this much amount of space that I have drawn on the screen, right? This block only 1, 2, 3, 4, 5, 6. 6 blocks were present, right? So after this, what will happen? Now, if the program wants to call the function f of 6 plus 1, 7. So what will happen? Anyone, can you tell me what will happen? Anyone, if I'm audible, are you able to follow this? So now again, when the value of x is 6, and the base case does not match and you want to run the recursive case, then what happens? What does the compiler do? Anyone? Can you tell me? Now you are making a call. Again, you are making a function, right? The area will be filled, right? Like this is answer. The right answer is correct. Like you want to call f of 6, 7, right? So what you will do, you have to store the program and all its variables into a memory, into some location of memory location, right? And if the memory is full, you can already see all the 6 blocks are full. You don't have any extra space, and you will. So this is a very hazardous situation right here, right, for us. And you won't your system will be stuck here, right? All the memory will be filled and nothing will work, or the operating system will crash and everything will crash, right? So in most of the modern compilers, for example, C compiler, GCC, has a check for this. So there is a limit on maximum recursion depth, right? So this error, you will see this error, maximum recursion depth. So you will observe this error, right? So for this case, the maximum recursion depth was 5. So you could make only 5 recursive calls. After that, the program will give, the compiler itself will prevent the program from calling the function again. So this is one interesting error that is observed. If you run a recursive program where the non-base case, the recursive case does not lead to the base case, right? There is no termination case here. Everyone, is this clear? Can we proceed further? So I need some confirmation from you guys so that I can be sure that you are able to follow what I'm saying right now. Right, everyone? Please type in the chat box, everyone. Am I audible? Or if you want to want me to skip this, then also I can just skip this. If you are everyone is able to understand this, then also I can skip this. I just want to make you guys familiar with why recursion and why these situation conditions are important in recursive programs. That's only the reason. So is this clear, everyone? So yeah, this is the issue here. So in this case, what was happening? The recursive case was not leading to the base case, and eventually the program was not terminating anywhere, right? So how can we correct this program? So so this program is essentially incorrect. But let's say if you wanted some version that works, but you don't know what the program is doing, so you can simply replace this plus with a minus sign. You can replace this plus with the minus sign. So you are always recursively calling the function f of x minus 1, right? Now when x is 2, you don't it does not reach the base case, but the value of it goes to the recursive case and it calls makes a function call. So yeah, let's create the memory here, right? Waste now again we have only 6 blocks. 1 2 3 4 5, right? So now again we the main function is stored here. Then you call the function f with value 2. Recursive case does not base case does not vary. The recursive case calls the function of func f of 1. Again the value x is equals to 1, 1 does not is not equal to 0. So you go to recursive case and you make a call to f of 0, right? Now what happens? As soon as x becomes 0, you reach the base case, right? Everyone? So what does do? This program returns 1. So when you call f0, it returns 1, and then all the values get traced back, and the stack is cleared eventually. So this is why you need a termination condition in your recursive program, and your recursive case should eventually lead to the base case, right? Yeah. So this was a brief introduction, a brief recap of recursion. If you still have any doubts, you can ask me. Now we are going to answer solve this problem, right? So what is the output for this program? So initially earlier we have already identified in our program that this is a recursive function, and you are making a call to this recursive function, right? Fun of 2. So inside the function fun, you are taking integer n, and this is the base case, right? So this is the base case, and this is the recursive case. We have identified these things. This is the recursive case, right? And inside the recursive case, I am calling the value return 2 into fun and plus 1, right? So let's solve this. Yeah. So how to process these problems, right? If you want to see what is going on, so let me just do one thing. Uh, Let me copy this program here and then answer this in a new page. Hmm. Right. Yeah. So now we have this recursive program and we want to see how it works. What is going on here? So initially the value of n is 2. So let's start doing this. Let me create a table and let's see what happens. What is return when, right? So I'm just creating a table here to track the values that we are getting, right? So initially I'm making a function call fun f of 2. So let me just use the number letter f here. It will be faster for me to type. 1f. Okay? Yeah. So we have f of 2, right? We are calling f of 2. So what happens? You go inside the main program, right? You go inside the function. So you go inside the function. So let me show the function block like this. So now n equals to 2. So base case is not true. So you are running the recursive case, right? Recursive case. So you are returning. So you are return 2 into f of 3, right? Now what will happen? We already saw that. Now what will happen? The function call f of 2, this entire call will be saved on the memory stack, right? And then what will happen? Now for processing this value, the return value from this function, you need to solve this function call, the function call to this value f of 3, right? You need to get the value of this term, second term here, then only you can return the value from this function. So this is how compiler also does this. So now you call the function f of 3, right? Now again we will see what is happen for f of 3. For the f of 3 call, what will happen? So n is 3. So it's not equal to base, its base case is not true. So what you will do, you will return 2 into f of 4, right? F of 4, right? Again, you function call and it's all its variable are stored onto the stack. And now what you want to do, you want to compute the value. So now new function call has been made f of 4 right here, right? So this function cannot return any value until unless you finish this evaluation, right? So this is how the program sequence works. So you move so you make this function call f of 4, right? So you call the value f of 4 and you see what happens here, right? So n equals to 4 here. Now you see it matches the base case, right? If n is 4, the base case. So yeah, our program was correct. Eventually it is case. So the program will terminate. There will be no stack overflow error here, right? So in the base case, what we are doing, we are returning the value n. So what is the value here? N, 4, right? So you return from here. So now how the program will unpack, how this value will be unstacked from the main memory. So now what happens? You remove this section, right? So dots. Yeah, so what happens? Like the value 4 is returned from this function call, right? So you backtrace from here to and you put this value here, right? So this f of 4 call returns, it returns 2 into f of 4. The value of f of 4 was 4, so it returns 2 into 4, right? Hmm. So it returns 2 into 4. Now what happens? So this function call and all its memory variables are freed from the main memory. Now again, this so for the function call f of 3, you know the value that has been returned from this function call is 8, right? From here. So now this program variables are erased from the stack, removed from the stack, popped from the stack, and the value 8 is returned. So now you get f of 3 as 8 here. So you put 8 here. And finally, this is the final first main call. So this also get removed and the final answer that will be returned is 2 into 8, which is 16, right? And now you are printing this value. So it will be printing 16. Right, everyone? Is this clear? Anyone do you have any doubts in this? Everyone, is this clear? Will you be able to solve these recursive functions on your own from now onwards? If I give you some random recursive function, you will be deduce what it is doing, right? So you should be able to understand how it is working, right? Great. So yeah, we know the answer. Option C is correct answer. Hmm. Option C, right? 16 will be printed onto the screen. Anyone do have any doubts? If you have any doubts, please type in the chat box. So every time you write recursive programs, pay attention that you should have a base case and the recursive case. And the base case should be lead to termination, and the base recursive case which should always lead to the base case eventually. So, right. So no one has any doubts. So let's proceed to the next program. So this was one topic that I was not able to cover in previous session. So if you still have any doubts, please type in the chat box, or we can start with this week's problems. Anyone, any doubts? Please type in the chat box, or we can start with this week's problems, right? So no one is typing anything, so I guess no one has any doubts. So in this week, what topics you were covered was so first structs. So structs are data structures that are used to store records in C program, C programming language, and then you were taught about pointers, then dynamic memory allocation, and finally uh, file handling, right? File input output operations. So these were the topics that were covered during this week, right? Everyone, are you familiar with these topics? So we'll start solving problems on these topics. Anyone? So let us start this problem, right? So I hope you are familiar with this things also. So everyone, are you familiar with concept of structs? So let me start with structs first. So are you familiar with structs, everyone? So the problems are also in the same order. So one, two, and three. Oh, sorry. So all the problems are also in the same order. First, I will cover problems from structs, then pointers, then dynamic memory allocation, and then file I. So I hope everyone is familiar with structs. So what are structs? Structs are data structures in C that can store values of different data types. For example, you can create a struct like this, struct, and you can struct s, and you can have it store two different values. One integer, one value belongs to the integer data type, and another value belongs to the character data type, right? So this is a very useful data structure in C that allows you to store data values from different data types into a single variable, right, everyone? Is this clear? Great. So The first question, what is actually passed if you pass a structure variable to a function? So, is this question clear to everyone? So, yes, right, right. Hmm. So now let's say you have a function called f, right? And that is function calls this struct variable, right? Struct s. So the name of this data type is s, right? So struct s input, right? And inside the function, you do some operations, and then you have a main function in which you are calling this function, right? In the main function, you're calling this function. So you're using this struct here and you're passing the struct here, right? So the question is, and inside the main function, let's say you have some struct declared like this, struct as data, right? And then you call the function over data, right? And inside the struct function, this f function, what you're doing, you are taking an input in the variable IP, and let's say you are saying IP dot x equals to 10 and IP dot y is equals to a character C, let's say, right, everyone? So, and let's say, so will what will happen to the data struct here? Now, let's say I print data dot x, right? Data dot x. So what will happen? Anyone? Right? If I'm printing, so yeah, like this is right. So some, so since the you have not assigned associated any value to the x variable data struct here, you won't you will get some random value, right? Some garbage value. But the question is, so when you so we are not interested in that for this program. For this question, we are interested what is happening to this data variable that is being passed in this function f. So is the copy of the structure passed? Anyone? Or the reference of the structure variable is passed, or the starting address of the structure variable is passed, or the ending address of the structure variable is passed. So these are the options for you. So when you pass this data structure here, you will see when you run this program, it will not print the value 10 here, right? It will print some random garbage value. But why? What is happening here? So there are two concepts in argument passing to parameter passing to functions in C. One is pass by reference and pass by value, right? In pass by reference, you pass the pointer, the address of the variable, and in pass by value, what you pass? You pass the copy of that object, right? Copy of that value, right? And for arrays, the parameter passing through pointers, so it passes the references to arrays. But for structs, it passes the copy of the structure variable. So option A is correct. So basically, a new struct. So now this IP is a new struct that contains two variables int x and character y. So the value of x here for this IP is different than the value of x for the variable data here, right? So that's why you were seeing garbage values. So what was happening here? Pass by value is happening, which says copy of the structure variable is being passed. Right? Is this clear, everyone? Hmm. Anyone is there? If there is some doubt, please type in the chat box right now so that I can answer your queries. So, to be able to answer this question, you need to be familiar with two concepts here. First one is what is passed by, so one is functions and how parameters are passed to functions from different functions. And the parameter passing is done in two ways in C. One is passed by value, one is passed by reference. In passed by value, you pass the object value, copy value or the variable is copied inside the inside the called function. So any changes to the variable in the called function does not get reflected in the callee function. For example, in the example here that I have shown here, so you are passing the struct data here to the function f, and you were changing the values there. These changes won't be affecting the variable data here itself, right? So the struct IP will be created as soon as the function is called, and it will be destroyed as soon as the function f exits, right? So this is of pass by value. In case of pass by reference, you instead of passing the copy of this object, you pass the reference to this object. You pass the memory location where this object variable is stored, and making changes at that memory location, essentially making changes at every place inside the program, right? In every function, caller as well as callee. So if you have any doubts, please type in the chat box or we can proceed further. Anyone do you have any doubts? So no one is answering. Is this clear, everyone? Great. So let's move on to the next question. Which function is used to write a string to a file? So this is the second topic. So this is a topic from file input output. So this is a objective question. So which function is used to write to a string to a file? Everyone, have you seen the lectures? You know the answer to this. All of above, right? Fputs is used to write unformatted string to output file. Fprintf is used to write formatted string to text files. Fwrite is used to write array values to files. So all of the above is true, right? And the question is, can you use all of these to write strings to a file? Right? Fputs and fprintf can be used, formatted and unformatted strings. And you can also use fwrite. Why? Because string is an array of characters, right? So if you want to if you can write arrays using fwrite, you can always use fwrite to write string to the file. So we'll be looking at the application of these functions in the later problem, right? I will use all these functions and show you how these work. Hmm. So question number 3, can a can a struct data structure, so those is struct as, can it contain a variable of its own type? So what does it mean? So it means, for example, you have a struct as, right? Struct as. Inside the struct, you have, let's say, an integer variable x, and then you have another variable struct s y. So is this correct definition of a struct? Is this possible? Is this allowed in C? So can the structure, we all know that the structs can store different variables of different data types, right? A struct can contain multiple variables of different data types. So can one of those variables can be the struct itself, right? That's the question. Can structure contain a variable of its own type? So the example is this program. So is this valid in C? Right, sure. This is not valid. So this is not allowed in C. So always pay attention. Option B. You cannot create a struct variable inside itself. You cannot create a struct containing a variable belonging to its own data type, right? You cannot. You can never do this, right? This is not allowed in by the default in the C compiler. So let's move on to the next question. Can a structure contain a pointer to its own type? So let me modify that question again. So let's say you have this struct S, right? And then inside this you have int x and a pointer, right? Struct S asterisk y. Is this allowed? Anyone? Is this allowed? Is this valid declaration? Yeah, this is correct. This is allowed. This is perfectly allowed. And this is very helpful in creating data structures that we know that linked list data structures, right? Yes, it is useful for creating linked lists data. What are linked lists? Linked lists are like data structures store. uh, so what are linked lists? Linked lists are data structures that store mm, uh, that are used to store collection of values, right? Values and structs used in creating. So how what are linked lists and how to use them, why they are useful, that you might be learning in your higher classes, higher courses. For example, in data structures courses, you will come across this linked list, and there you will see an application of this struct, how these structs are useful in creating those linked lists, right? And they have very beautiful properties of accessing and querying if value is present in the struct or not, in the linked list or not, and very fast referencing is possible in those scenarios, right? Anyone do have any doubts? So I guess no one has any doubts. So let's move on to the next problem. Find the output of the following program. So again, we have this standards stdio.h, and then we have the main function, and we are declaring a character array A with the following values, right? We are declaring and assigning the values right here. Hmm. And now we are so let's do this. So whenever you create an array in C, what happens is, so inside the main memory, so if this is your main memory, right? So whenever you create an array, a contiguous chunk of main memory, so a contiguous chunk of main memory is associated with that variable array, and its pointer to this. So this belongs to the array, right? The contiguous chunk in the memory, and pointer to the first value. So pointer, the address of this gets assigned to the variable whatever you are using, right? So let's say the memory address was 1000. So A will store the value 1000, the pointer to the memory location 1000, right? Now I'm so this is how this is you are declaring arrays in C, right? Now you are creating a character array A that contains all these values. So these values will be written in this contiguous memory location, and the value reference to the memory location 1000 will be stored to the variable A, right? Now what I'm saying in the next line, what I'm saying char asterisk P is equals to A. So what I'm saying, I'm creating a character pointer. I'm creating a character pointer, right? C. I'm creating a character pointer C that points to the memory location pointed by the pointer A, right? This is pointer assignment, right? On the left hand side, you have a pointer. On the right hand side, you have a pointer of the same data type. So you are simply copying the reference here. So now C points to this memory location, right? Everyone? And then what you are saying? Plus plus P. Plus plus P. What does this mean? Anyone? So let's say I'm saying one character occupies 4 bytes, right? So, and the value of P here was 1000, right? It referred to the memory location 1000. So what is the value of plus plus P? So now what will be the value of P? Anyone? It points to the next address, right? So I explained you guys like pointer arithmetic, how it works, why you need this character specialization for the pointer, right? So it will become the memory address to which it was referring to plus total number of bytes that is required to store one value of that particular data type. And for this character, I'm saying 4 bytes. So now P plus plus will essentially means 1000 plus 4, which is 1004. So now it will be pointing to the next memory block, right? 1004. Okay, great. So now we can just do the math, right? So so A was stored at memory location 1000, B was stored at 1004. So C would be stored at 1008, right? D will be at 1000 at 12. E will be stored at 1000 at 16. F at 1020. G will be stored at 1024. And H will be stored at 1028, right? Now our P is pointing to the value memory location 1004, which essentially points to the variable C here. Everyone, can you see this? So now P is pointing the variable C here, right? Now I am saying while asterisk P. So what asterisk is doing here? This is acting as a dereferencing operator, right? Yeah. So someone is saying that char occupies 1 byte of memory. I'm saying just assume there is a hypothetical computer that I am using right now that uses 4 bytes for storing a character, right? You can assume 1 byte also, then also you will get the correct answer, right? Just for now, hypothetically assume that it occupies 4 byte. That's it. Yeah. So now this asterisk here, what it's doing, it is dereferencing. So by dereferencing, what I mean, the value stored at the memory location pointed by P, right? This is equals to value at location. So this is the refreshing pointed by P, right? So whenever you apply a asterisk operator over to a pointer, it acts as a difference dereferencing operator. This has already been covered in previous sessions, right? So while the dereferenced value at P is not equals to E. So now we are doing what we are doing. This is not equals to operator. So we are doing character comparison, right? We are doing character comparison. So let's start doing this. Let's finish this. What you have to do, you are using percentage %C. So this is a format specifier for character, and you are printing asterisk of P plus plus, right? So this means you use the value, you print the value stored at the memory location pointed by the pointer P, and then make P equals to P plus 1, right? So what this essentially means, this means in layman terms, print asterisk P, and then in the next line P plus plus, right? So or I can say P equals to P plus 1 because it's postfix, so it uses and then change the value. So P equals to P plus 1, right? So let's do this. So in it, the what is the value of P that we observed here? It was 1004. So what is stored at memory location 1004? B, right? And we are printing P. So what it will print? It will print B, right? Now what is the value P stores? P becomes, now P becomes the loop. So now you go back to the loop state starting, right? And the value of P becomes 1008 because you are incrementing by 1, right? So what is the value at memory location 1008? The value is C. Is C equals to E? No. So the loop will not exit and you will again print some value. What value you will be printing? You will be printing the value pointed by the location 1008. So 1008, at 1008 you have stored C, right? So you will print C here. Again you increment P by 1, so P equals to P plus 1, so P becomes 1012, right? So now what is stored at memory location 1012? The value stored at memory location 1012 is D, right? Is D equals to E? No, D is not equals to E. So what you do, you go inside the while loop and you print the value located at the memory location 1012. The value is D. D will be printed here, right? Again, you call the function P equals to P plus 1. So what is the value, new value of P? P becomes 1016. Now, what is the value stored at the memory location 1016? The value is E, right, everyone? You can observe that at 1016, E is stored, right? Now, you go back to the while loop and you see what is the dereferenced value at memory location 1016, E. Is E equals to E? Yes, E equals to E. So what this do? The loop exits, the loop breaks, and then nothing else is printed and the program returns 0 and you get your answer, right? BCD will be printed onto the screen. So the correct answer is option B. Option B. Right, everyone? Is this clear? So I essentially opened up the entire program for you guys, and then we saw what is happening here. Anyone do you have any doubts for this program? If you have any doubts, please type in the chat box. If you want me to explain this again, I will explain this again. If you have any queries, just type in the chat box, right? Great. So it seems everyone is able to catch this up. So yeah, let's move on to the next problem. So now what we have a code snippet and we want to see what is the output of this code snippet, right? Let's see. So we have a structure variable, a variable point that belongs to the structured data type, right? So what does structure mean? Struct means we can this means this variable has can have multiple variables of different data types. In our case, this with each struct has two variables. One is x, one is y. Both belong to the data type integer here, right? So we have observed how this struct is defined. So let's move on to the next line in the program. So then next line says we are declaring a struct point asterisk ARR2. So let's see what this line means. So the first two statements says, so we are going to create a variable of data type struct point, right? This is how you declare structure variables, right? So struct point. So you are going to declare a variable of data type struct point, and then your variable name comes here. Now there is a difference here, right? You are observing this asterisk here, and then you are declaring some variable, and then you are creating these two brackets, this bracket. So what does this mean, right? So in an analogy, it's let's say if I had some variable of integer data type int variable, right? And then I have another declaration int asterisk var p, right? So what is the difference between these two lines? Anyone? By now you should be able to understand this difference. You should be able to distinguish this. So I'm just giving an analogy like how to decode what this variable means here. So for example, if you had some integer variable var and then another integer variable asterisk var p, this essentially means you are creating an integer variable, and this contains some value. And now this asterisk var p means you are creating a pointer to an integer, right? Right, everyone? One int is variable, other is a pointer to that to variable, and I can always say var p, assign the address to the variable var to the variable var p, right? Everyone, I can use every time I can use this ampersand operator. You remember this? This gives the reference, right? This returns the reference. So it is used for getting the reference of the input of a variable where the operation is going on, right? So using the same analogy, we can see we are creating a variable of data type struct point, and what that variable is, this is a pointer, right? This is pointer variable. Well, also you are using this square brackets here, right? So we remember what is this square value signify? It signifies an array, right? So now, so this is an pointer variable that will point to a structure, right? But instead of having one single variable ARR, I am having an array, and that array contains two references. It can store two references, right? So if you look at the pointer array, it has two, it has a space of two, and these both two are belong to the data type of struct. So yeah, let me just expand this. And so now you are, instead of declaring as primitive pointer variable ARR, I'm creating an array of pointers, right? So this is always allowed in C. You can always create array of pointers in C, right? So this ARR would look like this. So these are index 0 and index 1 values. So you can store pointer to struct point, right? Point asterisk. So it contains two pointers in itself because it's an array of pointers, right? Struct point asterisk. So you can always assign references to two variables belonging to the data type struct point to this array, right? Now let's move on to the next line. I hope this is clear. In the next line, I'm creating a struct point variable p1 with the values 1, 2, and p2 with the values 3, 4, right? This means we have created p1 dot x should be 1, p1 dot y should be 2, again p2 dot x should be 3, and p2 dot y equals to 4. So this is how you declare and assign values to us structure variables in C. Now let's move on to the next line. I am saying ARR at 0 equals to ampersand P1, right? So at the index 0, at the index location 0, that is here, you are storing the reference to ampersand. You can see this ampersand operator, right? What it does, it returns the references. We already saw this in previous lectures, right? So it returns the reference to the pointer variable p1, and you store that reference at the array arr in the index location 0. So this index location now contains the reference to ampersand p1, right? Now again arr at 1 equals to ampersand p2. So again, this index 1 in the array contains the reference to variable p2, ampersand p2, right? So in the so you can always say that in the main memory, right? If this is the main memory, so let's say p1 is stored here and p2 is stored here somewhere, right? And this is the memory location, let's say 1000, and this is the memory location 2000. So now arr will contain 1000 here, and ARR at 0 and ARR at 1 will contain 2000 here, right? So this is what this actually means. So that's a lot of stuff to be taken care of for understanding this program. So I hope you are able to follow me whatever I'm explaining here, right? Now what I'm saying, printf percentage %d. So format specifier for integer, right? You all know this. Remember this, I hope. And then you are printing the value ARR at 1 dash y. So yeah, there is one mistake in my so yeah, there's a pointer, right? Yeah. So, so what is the reference of ARR at 1? So ARR at 1 refers to the memory location 2000, and then you are using these arrows. So what are these arrows? These arrows are operators. These are operators over pointers, right? So whenever you see this arrows in C programming language, right? This arrow here, these basically are used to access the value. So these are essentially uh, used to access value stored at the referenced location, right? So this you will observe these arrows every time in C programming language whenever there is some pointer, right? So ARR is a pointer variable. We all know this, right? And ARR at 1 is a pointer for ARR is an array containing pointers, and so ARR1 is a pointer variable. And what is the value? So you want to so this is equivalent to, if you want to see the equivalent definition to this, the equivalent definition looks like this: asterisk. So it is basically dereferencing. Asterisk ARR at 1, right? So you dereference it dot y. This is equivalent to this thing. So these two are same. So you dereference the memory location at 1, so ARR at 1, which is 2000, and then you get a struct point, right? Struct point variable, and what is the value of y variable in that struct variable, right? So it points to the memory location 2000 where the reference to pointer to p2 was stored, and what is the value of p2 dot y? P2 dot y is 4, right, everyone? P2 dot y is 4, so you get the answer D. Option D is correct. Is this clear? Everyone, is this clear? So it requires it like this problem requires a proper understanding of pointers, arrays, as well as structs in C, right? So try to get familiar with this arrow operator in C. whenever you observe these, you know that note that these essentially these are being applied to a pointer itself, pointer variable, right? If you have any doubts, please type in the chat box, or we can move on to the next question. Everyone, please confirm once by typing in the chat box if this is clear or not, right? Great. Okay. Hmm. So, so these were few basic problems where we were required to get the answer of the program. So someone is asking, will they ask us to write programs in the exam? I'm not sure about this. So the NPTEL team can help you with this. I cannot say anything on that, right? Yeah. So till this point, the topics that I have covered is structs. So I have covered structs, right? I have covered pointers, and I have covered only these two topics, right? Till now, I have only covered these two topics in detail. So now, two major object topics that I need to cover today are dynamic memory allocation and file input output, right? So even for file input output, you already saw one problem where you were asked which of the function can be used to write a string to a file, right? So now we'll be doing, I will be explaining the remaining topics using some problems, some programs, right? So these are the programs that I will be solving, and with which I will be explaining how these functions work, how to do file IO. But before starting, I would like to take a break for 2 minutes, right? So I'll be back. I just need to get some water to drink, and then we'll resume, right? But, just wait for a few minutes. So, hi everyone, welcome back. So, let's resume our session. So, I already shown you the programs that I will be solving, that I'll be writing for you and explaining the use cases of this programs, right? So, let's look into the puts function, how it works, what it does. So, what is puts function? It is used to write unformatted strings to text file, right? So I hope you are familiar with files. What are files? So files store data on the on your CPU program computer, right? So you have to use fputs here, right? Right. So the syntax of this function looks like this. So it returns some value, right? An integer value, and the function variables are arguments are constant character string. So it basically the string that you want to store. So character pointer, right? Character pointer containing the string and the file stream. File stream is what? File stream is basically the input output stream at which you want to put the value, right? So this is the pointer to the uh, file object, right? So how does this file object looks like? It is of belongs to the type file. It's a file pointer file, and then let's say if you want if has the function f open to open the text file for doing operations like file.txt, and you want to write something to it, so you will use the write mode here, right? And then you can simply pass f puts, and then yeah, this is how f puts works. And then this char pointer string contains any string, right? You can put any string and you can store to this file, right? So let's see a C program and let's see how it works. So was my screen visible this whole time? Oh, yeah, sure. Hmm. Was my screen visible for this whole time? Okay, just let me share this again. Right, I hope everything should be visible now. So let's start. Hmm. File io1.c, right? So we include standard IO library, right? Standard input output. Then we declare the main function. And since we are using int, So you return 0 here. Now, what I want to do, I want to do file IO using f puts, right? So let's see how it works. So the syntax to this is how f puts looks like. So this is a function that returns some integer, and the input arguments are constant character pointers. So this can be any string that you want to write to a file object, right? So it's file object, right? Pointer to a file object. This is how it's so strem. So this is how the syntax looks like for this function, right? So basically, so you have to pass in some stream here, right? And for now, what this stream looks like for us, this stream can be a text file where I want to write some output, right? So this is the syntax. So let's first create a character pointer string, and let's type in any string here, right? We want to write this string to a file. Let's say I want to let's say yeah, I want to write this string to a file onto your disk, right? So for this, you have to create a stream pointer stream, and then you can use the fopen function to open a file for this. And let's call it file io1.txt, and we want to write open the file in write mode. So let's pass w here, and then what I can do, I can simply call the function fputs. So so it returns an integer value. Let's store that return value. So retval is equals to fputs, right? And I can pass the character pointer and stream to the function, and then if retval equals to 1, then I can tell the user that. So it returns 1 if the file IO is successful, file IO is successful, and it returns 0. So if it returns 0 if file IO failed, right? So this is how this fputs works. So let's go ahead and compile this program, right? And then I can run the program. Okay, any string. Okay, okay. Hmm. So there is some mistake in this. So just one thing, let me confirm this. Okay, so yeah, I get this. Yeah, so this is clear what it does, right? So basically, if retval is 0, this means nothing was written on the onto the file, so it failed. Else, if it's returning any other integer, it succeeded, right? And wrote this many characters to the file, right? So in case the file IO is successful, what it does, it returns the number of characters that have been written, right? This is how essentially its syntax works. So now I can simply compile it and run this program, and we can see we can see it's saying file IO succeeded and wrote 10 characters into the file. So let's check our file, right? File io1.txt. And you can see it contains the string any string. Everyone, can you observe this? Is this clear how we are using this fputs function here? Anyone, do you have any doubts? So here we are using file stream as a output destination. So this string can be anything. It can even be a your output terminal, standard output terminal. But right now I'm redirecting that output to a file, and you can see I am writing some any string to this, right? Okay, great. So let me do one thing. So this is line 2 backslash n is line 3, right? Hmm. Right. So this is how fputs works. So in this example, what I did is I wrote multiple lines onto the same file, right? So this is line 1, this is line 2. So I'm separating the lines using the backslash n line change operator, right? Backslash n is used to change line in strings. And you can see we will obtain 3 lines in our program. So you can see we have 3 lines in our program. First line says any string, second line says this is line 2, third line says this is line 3, right? Okay. So this was an example that uses fputs. Fine. Right, everyone? You have any doubts? Someone is asking, we can directly assign values to pointers. You can assign the values, right? You can always directly assign values to pointers as other variables. Anyone? Any doubts? Right, everyone? Do you have any doubts? Please type in the chat box. So there are few things that we need to cover since we are working with these strings. So there are a few things I would like to cover with these, right? So what is this file here, right? What is this file data type? What is this? Why I am typing this file name here? Why I'm using this fopen function and then writing the file name here and then I am passing w here. So what is the meaning of these things, right? So let me cover this and then we can start from proceed from there. Yeah, so let's go back to the fopen function. So let's see what it's doing. Right, we saw that we were using fopen function and then I'm passing w here, right, everyone? So what is this? And let's look at this f open function. So what f open does is it opens our destination stream, file stream, and returns the pointer to that stream, right? And the first input is this file name, right? So this is essentially file name, right? And the second one is mode. So in which mode you want to open this file, right? So if you just want to read it, the value would be R. If you want to write, you can pass write. And then there are other modes also that you can look up on the internet. So for your reference, I can uh, right. So for the other most common one is append mode that uses the character A here. Then two more are there, R plus and W plus, right? So these are different modes in which you can open a file. R plus, W plus, and A plus, right? So these plus ones are useful when files are not present, and these are useful. Yeah, anyways. So these are different modes in which you can open up the file, right? So this is how this f open function works, and it returns an pointer to the file object here, right? File pointer to this stream here, right? So this was the f open function, and the program that we saw you solved uses f puts. So f puts, what it does, it can only print straightforward character arrays onto the text file. It cannot do any formatting or parsing before writing the string onto the text onto the file. So we will see what do I mean by this, right? So by just doing the example for f printf function. So we already saw f puts function. Anyone, do you have any doubts? Please type in your doubts. Till then, there is query from light. So light, is this clear? So we can directly assign values to pointers. Is this clear to you? Uh, right. This is very straightforward. We have been doing since long time, right? So, for example, for this program also, I was saying char asterisk p equals to a. I'm directly assigning the value here, right? So, light, which what you want me to explain? Can you just point out what you want me to explain? The program that we do for f puts or this f open function, what you want me to explain again? So there are two things that I solved for this problem. One, I explained the f puts function, and then second, I explained the f open function. Which one of these you want me to explain again? Or you are just asking the question, we can directly assign, whether we can directly assign values to pointers or not? The answer to that question is yes, we can directly assign. We have already saw the examples in previous programs also. So Light, please confirm so that I can proceed. What you want me to explain again? Acha, ठीक है, great. Yeah. So let's. So you saw the example, right? In this program itself, I'm saying char asterisk p equals to a. This line. If you pay attention to this line, it is already doing the thing that you are asking, right? It is directly assigning the value to this pointer p, where the point variable is declared itself, right? Yeah. Right. So let's move forward to the next problem. So I'm saying it only works with unformatted strings. So pay attention to this term unformatted here. What does this mean? Let's see with the next example, right? Next problem. So we want to use fprintf function. So let's go to fprintf, right? Printf. Right, right. So this is the syntax for fprintf. It again returns some integer value, the total number of characters being printed on the file, written on the file. Then the first argument is the file character, file stream, the destination where you want to write the output. You want to write the string, right? And this and the so right, this is the first argument, file stream. Then this is the second argument, some constant character, right? So this is a character of array string, right? So this is formatted string. So let me just update this, right? I can write formatted string, some formatted string here, and then this triple dots. What are these triple dots? Why do we need this? So let's pay attention to this triple dots. This is really interesting here. This is one thing that has changed from f puts to f prints, right? Until here everything was same. You were outputting some string onto the file, some object file stream file, but now you have these triple dots. So let's see what do these mean, right? So to understand this, I want to ask you one thing. Do you remember the printf function? So do you remember the printf function, everyone? So you're writing some string, then some format specifier, for example percentage d, and then comma, and then you are giving some value here, for example 9 here, right? Do you remember this, everyone? I hope you remember this. Like I have been doing this for a long time. So now let's say int n equals to 9 and you want to print the value stored in the variable 9, right? So these kind of strings are known as formatted strings. So this is a formatted string, right? So what, why formatted? What I mean, the compiler, the program, oh, sorry, document closed. By formatted string, I essentially means that the program itself first formats the string based on the given instructions, format specifiers, and then only the operation is performed, right? So these are formatted strings. So in the printf function, we have been using these formatted strings for a long time, right? Now, let's say I want to write something. I want to write this string onto the file, right? I want to write this, but you can't do this using f puts, right? In f puts, what you will go, you will give some file object, some string here, right? Some string, and then you give the file file here, right? There is no way you can add this n to this string and write using fputs, right? Fputs does not process the string at all, and you want to write the value of variable n or any other variable present in your program into the output file, right? For that, you need something that actually parses this string. So basically reads this entire string, processes it, and generates a character array and then puts it onto the file. For that, you can use fprintf. This is where fprintf comes in handy. So you pass in the file and you pass some string and then the format specifier, and after that you put a comma, and in place of these triple dots you can put in that variable name, or essentially any integer value also, like percentage d, that form the value belonging to that format specifier. We have been using for a long time, right? So this is the difference that fprintf allows us, which fputs was not allowing us to do, right? It is allowing us to format the string and then writing to the text file. Right, everyone? Is this clear? We'll be looking at the, so you already see the difference here, right? Fine, everyone, is this clear? Do you have any doubts? Is the difference clear? Anyone please confirm. If it's not, then I will show the program and I will explain it again. Yeah. So this is the difference like between a formatted and formatted string. So if fputs did everything, then you won't need print this fprintf, right? But you need it because there is something that is being missed by fputs, and that thing is string formatting, right? So let's go ahead and write the program and see the output yourself, right? So I will just uh, copy the file c to file io 2.c, right? Let's open up the file io2.c, and in this I'm using, so again I'm opening the file io2.txt in the mode write, right? The mode is w means write mode, and the string is, so now for the string we will not using fputs, we are using fprintf, right? Fprintf, and first you pass in the stream variable here, and you pass the string, so any string, and then let's say you add a format specifier percentage %d to print the value stored in an int variable n. Let's say int n equals to 9, right? Now this will do this, right? So let's see. Everyone, is the program clear? I've explained the syntax in the word file, and now I'm writing the program itself. So here you can see I am using this formatted string. I'm not passing this blank string here, right? So I'm using this formatted string here. So let's compile and run this file io to. So we have successfully compiled our program. Let's run this. And you can see the prompt file IO succeeded and 12 characters have been written to the file. So let's see the program. Let's see the file, right? File IO2.txt. Any string 9. Can you see this? This value and 9 has been written on the file, everyone. Which you so the 9 is the value that character n stored in our program. Do you remember this? Is this clear, everyone? Everyone, is this clear? Do you have any doubts? So this was the program, right? This was the program, and this was the output stored on the text file io2.txt. Right, everyone? So let's say if I say n equals to 90 here, then you will see the difference will be visible. So let's run the program again, compile the program again, then run the program, and then open up the file output, right? Right now you can see it has printed written on the file any string 90. Right, everyone? Is this clear? If you have any doubts, please type in the chat box. So this was the program. I was writing the value of variable n into the text file. The value is 90 here, right? So this is how you do file IO in C, right? So only 10 minutes are remaining for today's session. So I want to ask you guys if you have any doubts, and we will cover the remaining problems in tomorrow's session. So tomorrow is an extra class from 3 to 5. So I will be explaining the remaining problems there, and this will be a revision class. So if you have any doubts, you can ask me there. Now, for today's session, do you have any doubts? So officially, the session is over by my side, right? And if you have any queries or any doubts, you can ask me right now. Or and if you don't have any queries, you can leave the session, right? Feel free to leave the session. So yeah. So if you have any queries, please type in the chat box.